Welcome to these gentle, soothing stories for sleep. I am so glad you are here, choosing to end your day by drifting into the quiet wonders of the universe. Tonight, we will begin a long and peaceful journey together, a journey into the immense and beautiful silence of space. We will let go of the noise of the day and allow our minds to settle into a state of deep calm, carried along by the slow and graceful rhythms of the cosmos. Before we begin our meditation, I would love to know where you are listening from tonight, or perhaps how your day was. Your stories and your presence here make this journey all the more special, so please feel free to share a thought in the comments below. And if you find a sense of peace here with us, please support our channel with a like and subscribe, so that we may continue to share these quiet moments together. Thank you so much. Now, find a comfortable position. Close your eyes if you wish, and let your breath soften as we begin our first of 50 meditations on the silence of space. Let us begin with a sound, or rather, the idea of a sound, here with you in your room. Perhaps it is the gentle hum of a distant machine, the soft whisper of air from a vent, or the rhythmic beat of your own heart, a quiet drum against the stillness of the night. Every sound you have ever known, from the loudest crash of thunder to the most delicate sigh, shares a common, beautiful secret. It is a traveler. Sound is a vibration, a tiny, invisible ripple sent through the world, a pressure wave that journeys through the air, through water, through solid ground, carrying energy from one place to another until it finally reaches your ear and is translated by your mind into the rich tapestry of the audible world. It needs a medium, a substance to carry its message. Like a boat needs the water of a river to float downstream. The air around you right now is a vast, invisible ocean, and every word, every note, every rustle of your sheets is a wave traveling upon its surface. Without this ocean of air, without a medium to carry the vibration, there can only be a profound and unbroken quiet. This is the first and most fundamental truth of space. It is a near-perfect vacuum, a realm where the ocean of matter has receded so completely that the waves of sound have no water in which to travel. The space between the stars is not truly empty, of course. It is filled with a tenuous mist of individual atoms, a phantom breath of hydrogen and helium scattered so widely that one could travel for miles before encountering another. But they are too far apart, too disconnected, to pass a vibration along. They are lonely islands in an impossibly vast sea, unable to whisper to one another. And so, the universe is overwhelmingly, deeply, and beautifully silent. This silence is not an absence, but a presence. It is the canvas upon which everything else is painted. Imagine the most spectacular cosmic event. 2 galaxies, each containing hundreds of billions of suns, slowly, gracefully, colliding with one another over millions of years. Stars and gas clouds merge in a celestial dance of unimaginable scale and energy. And yet, if you were there, floating in a ship just beyond the chaos, the entire spectacle would unfold in absolute, deafening silence. The fires of 1 trillion stars would burn without a crackle. The shock waves of exploding suns would expand without a boom. It is a silence that changes our perspective, inviting us to witness the universe not with our ears, but with our eyes and our imagination. It suggests that the grandest truths and the most powerful events do not need to announce themselves with noise. They simply are, existing in a state of silent magnificence. This cosmic quiet is a gentle invitation to your own mind, a permission to let the noise of the day fade away, to release the countless conversations and concerns, and to simply be present with the quiet majesty of what is. In this vast stillness, another kind of messenger reigns supreme. Where sound cannot travel, light embarks on its incredible, silent journey. Light, in all its forms, from the radio waves that carry whispers between satellites to the brilliant visible light of a distant star, is an electromagnetic wave. It does not need a medium. It does not need an ocean of air or water to carry it. It is its own traveler, a self-propagating wave of energy that can cross the deepest voids of the cosmos, carrying with it the story of its origin. This light travels at the ultimate cosmic speed limit, a constant known simply as c, approximately 300,000 kilometers per second. It is a speed so immense, it is almost beyond our ability to truly feel, and yet it defines the scale and the story of everything we see. When you look at the moon, the light that enters your eyes left its surface just over a second ago. The light from our own sun is on an 8-minute journey before it warms your skin. But when you gaze upon the nearest star, Proxima Centauri, you are seeing it as it was over 4 years ago, its light having travelled silently across trillions of kilometres of the vacuum to reach you. And the faint glimmering stars of the Milky Way are whispering stories from thousands, or even tens of thousands, of years in the past. Light is the universe's silent language, its ancient memory. Every photon that strikes your eye is a messenger from another time and another place, having completed a voyage of unimaginable length and loneliness, a journey through the perfect quiet. And so, as you lie here, preparing for sleep, you can imagine your mind as a quiet observatory, your consciousness as the deep, dark sky. Let the thoughts of the day become like distant starlight, not loud or demanding, but silent, gentle points of light from a time that has already passed, their energy fading as they complete their long journey into the peaceful quiet of your awareness. The universe holds this stillness for you, a vast and patient silence that has existed for billions of years, a deep and calming presence that asks for nothing but to be witnessed. And so we rest within this vast and patient silence, a deep and calming presence that asks for nothing but to be witnessed. And as we witness it, our gaze is naturally drawn to the brightest and closest messenger in our night sky. The light that travels from the distant stars finds its counterpart in the gentle, reflected glow of our silent companion, the moon. It hangs in the darkness like a pearl, a familiar face in the infinite void, its soft, silvery light, a tranquil balm for a tired mind. For all of human history, it has been our constant neighbour, a silent keeper of secrets, a gravitational anchor in our celestial dance. Its silence is even more profound than that of the space between worlds, for it is a world in itself, a world without a voice. Its familiarity is a beautiful illusion of celestial mechanics, a phenomenon known as tidal locking. Over billions of years, the gravitational pull of the Earth has gently slowed the moon's rotation until its rotational period perfectly matches its orbital period. The result is a cosmic synchronicity, a perfectly choreographed dance where the moon always presents the same face to us, forever hiding its far side. This consistency is deeply comforting. It has become the face of the night, a dependable and serene presence. We can look up and see the same patterns of light and shadow, the same vast, dark seas of ancient lava, and the bright, cratered highlands that our most distant ancestors saw. It connects us through time, a silent, unchanging observer of the entirety of the human story, a quiet reminder that while our lives are fleeting, some things in the cosmos have a deep and abiding permanence. This ancient, silent face is covered in a material as quiet as the void itself, a fine, powdery dust known as lunar regolith. It is not like the soil or sand of Earth, which is shaped by the ceaseless action of wind and water, processes that are inherently noisy and dynamic. Lunar regolith is the product of a slow, silent violence. For 4.5 billion years, the moon, unprotected by an atmosphere, has been continuously bombarded by micrometeorites, tiny particles of cosmic dust and rock travelling at incredible speeds. Each impact, a silent flash of energy, pulverizes the rock, creating a fine, flour-like powder that now blankets the entire surface, meters deep in some places. The footprints left by the Apollo astronauts in this dust remain perfectly preserved, sharp and clear in the vacuum, as if they were made only moments ago. There is no wind to soften their edges, no rain to wash them away. They are silent monuments in a silent museum, testaments to a fleeting visit in an environment of timeless stillness. To meditate upon this dust is to contemplate a history written by impacts rather than erosion, a story of accumulation rather than change. It is a landscape of profound peace, where nothing has stirred for millennia, save for the occasional, silent fall of another tiny cosmic stone, a quiet that is the very texture of the world itself. Let your own mind settle like this lunar dust, letting the agitations of the day come to a soft, undisturbed rest, finding a state of inner quiet that is deep and pristine. The profound silence of the moon is guaranteed by its almost complete lack of an atmosphere. On Earth, our sky is a thick, protective blanket of gas that scatters sunlight to create a brilliant blue that carries weather systems across continents and that allows the vibrations of sound to travel. The moon has no such blanket. Its gravity is too weak to hold onto a substantial atmosphere, and so its sky is perpetually, perfectly black, even when its surface is bathed in the brilliant, harsh light of the sun. On the moon, the stars do not twinkle. They shine with a steady, unwavering intensity, their light not having to pass through the turbulent, shifting air of an atmosphere. The silence is therefore absolute. No wind whispers across the plains, no storms rage, no sounds echo in the valleys. The only weather is the slow, silent creep of the sun's terminator line across the landscape, plunging the surface into the deep cold of night or raising it to scorching temperatures in the day, a transition that occurs without a single sound. This absence of a voice makes the moon a place of pure being, a world of form and light and shadow, but not of sound. It invites a different kind of perception, a direct experience of existence without the filter of atmospheric noise. As you lie here, imagine this perfect clarity, this silent sky full of steady, unblinking stars, and allow your own inner world to become just as clear, just as uncluttered by the noise of thought, feeling the deep peace that comes from such a pristine and silent state of being. And yet, for all its silence and apparent separation, the moon is not a passive observer. Its influence reaches across the 384,000 kilometers of silent space to touch our world in a deep and rhythmic way. Its gravity, a silent and invisible force, pulls upon the Earth, and most noticeably upon our vast oceans. This pull creates the tides, the slow, predictable rise and fall of the sea level along our coastlines. It is a colossal movement of energy, a planetary scale breath, all conducted in utter silence. The moon does not need to speak to exert its power. Its mere presence is enough to shape the rhythms of our world, a rhythm that has guided sailors, influenced coastal ecosystems, and perhaps even played a role in the very origin of life on Earth by mixing the waters of the primordial seas. This silent, gravitational connection is a beautiful metaphor for the subtle yet powerful forces that shape our own lives, the quiet influences of people and places that guide us without a single word. The moon is our partner in a gravitational waltz, a silent duet that has been performed for eons. It is a reminder that the most profound connections are not always the loudest, that presence itself can be a powerful force, and that even across the greatest of voids, there can be a deep and unspoken bond, a silent harmony that holds the world in a gentle, rhythmic embrace. This silent harmony that holds our world in a gentle, rhythmic embrace extends far beyond the Earth and its lonely moon, for we are but one small part of a much grander and more intricate performance. From the silent, gravitational duet of our world and its companion, we can now gently pull our awareness back, expanding our perspective to encompass the entirety of our solar system, a vast and silent clockwork of worlds, all bound in a slow, celestial dance. Here, in the deep quiet between the planets, the same invisible force that orchestrates our tides reigns supreme, a universal law whispered into the fabric of space-time by the presence of mass itself. This is the law of universal gravitation, a simple and elegant rule discovered by Isaac Newton, which states that every object in the universe gently pulls on every other object. It is not a harsh command, but a persistent, silent invitation, the tendency for matter to gather, to orbit, to dance. The Sun, containing more than 99% of all the mass in the solar system, exerts the most profound pull, its immense gravity curving the path of every planet, every asteroid, every speck of dust, guiding them along their ancient, elliptical tracks. To contemplate these orbits is to meditate on a perfect and enduring peace, for they are paths of least resistance, a state of perpetual falling that never arrives, a perfect balance between the forward momentum of a planet and the inward, silent call of the sun. For billions of years, this silent dance has continued, a testament to the elegant and unspoken order that can arise from a single, fundamental principle. As we drift through this silent, orderly system, we can witness the unique character of each of the planetary dances. Closest to the Sun, we see the small, rocky worlds, the terrestrial planets. There is Mercury, a silent, cratered sphere, scorched and frozen by its proximity to the Sun and its lack of atmosphere. There is Venus, shrouded in a thick, toxic blanket of clouds, its surface a silent inferno of crushing pressure. And there is Mars, the quiet red planet, its thin atmosphere occasionally stirring into silent, globe-spanning dust storms, its canyons and dry riverbeds, the silent ghosts of a more active, watery past. These are worlds of substance and stone, their silence, one of geology and ancient stillness. Then, as we travel further out, beyond a great belt of rocky asteroids, we encounter the gas giants, worlds of a completely different nature. Here is Jupiter, a colossal sphere of hydrogen and helium, more massive than all the other planets combined, its atmosphere a swirling silent tapestry of storms, including the Great Red Spot, a cyclone larger than our entire Earth that has been raging in complete silence for centuries. And beyond lies Saturn, the serene jewel of the solar system, its famous rings, a vast, flat disk of countless individual particles of ice and rock, each one in its own silent orbit, forming a structure of breathtaking and ethereal beauty. These giant worlds have no solid surface to stand on. They are places of immense and silent weather, of clouds and winds moving according to complex fluid dynamics, all without a single sound wave to carry their story. Each planet, whether a quiet stone or a swirling storm, adds its own unique note of silence to the grand, cosmic symphony. This entire collection of worlds, from the smallest moon to the largest gas giant, follows a remarkably consistent path, orbiting the Sun in more or less the same flat plane, a cosmic disk known as the ecliptic plane. This is a silent memory of our solar system's birth. Long ago, before the Sun and the planets existed, there was only a vast, cold, and slowly rotating cloud of gas and dust. As gravity began to pull this cloud inward, its rotation increased, just as a spinning skater pulls in their arms to spin faster. This spinning motion caused the collapsing cloud to flatten into a disk, a protoplanetary disk, with the young Sun forming in the dense, hot center. It was within this spinning, silent disk of material that the planets were born, slowly gathering matter together through countless gentle collisions, their shared origin forever inscribed in their common orbital plane. To visualize the ecliptic is to see the ghost of our own creation, to understand that the order and harmony we witness today are not an accident, but a direct and silent consequence of our beginnings. It is a reminder that our present movements are shaped by a distant past, that we are all part of a shared heritage, a shared journey that began in a silent, spinning cloud of stardust. And within this shared dance, there are even subtler, more intricate rhythms to be found, quiet harmonies that emerge over the vast timescales of celestial motion. This phenomenon is known as orbital resonance, where the orbits of two or more bodies are related by a simple ratio of whole numbers, their gravitational influences reinforcing each other in a regular, rhythmic pattern. For example, for every one orbit that Neptune completes around the Sun, the dwarf planet Pluto completes exactly two, a silent 2 to 3 resonance that keeps their paths stable and prevents them from ever colliding. Jupiter's largest moons, Io, Europa, and Ganymede, are locked in a 1 to 2 to 4 resonance, a precise and silent harmonic relationship that shapes their orbits and even drives the volcanic activity on Io. These resonances are like the subtle harmonies in a piece of music, hidden relationships that create a deeper layer of structure and beauty. They are the universe's quiet poetry, a mathematical elegance that unfolds in the silent movements of the heavens. It reveals that the solar system is not just a collection of independent dancers, but an interconnected system, a family of worlds that subtly and silently communicate through the gentle, rhythmic language of gravity, all circling the great, central anchor that holds them in its sway. They are all circling the great, central anchor that holds them in its sway, a star we call the Sun. We see the planets only because they reflect its light, their dance choreographed by its immense gravity, their very substance born from the same cloud that created it. And so, our journey through the quiet of our solar system must inevitably lead us to its heart, to the silent fire of the sun itself. Here we encounter a profound and beautiful paradox. The sun is a place of unimaginable violence, a continuous thermonuclear explosion 1,000,000 times the width of our Earth, a churning, boiling sphere of plasma where temperatures reach 15 million degrees Celsius at the core. It is, by far, the loudest and most chaotic place in our entire cosmic neighborhood. Yet its power, its light, and its warmth all travel across 150 million kilometers of empty space to reach us in absolute, perfect silence. We are warmed by a fire we cannot hear, given life by an engine whose roar is lost to the vacuum. To meditate on the sun is to embrace this paradox, to understand that the source of all our energy and life is a silent gift, an offering of warmth that asks for nothing in return. It is a constant, dependable presence in our sky, a silent furnace whose steady light has nourished the earth for billions of years. This silent, life-giving fire is powered by the most fundamental process in the universe, nuclear fusion. Deep within the sun's core, the pressure is so immense, the gravitational squeezing so intense, that individual hydrogen atoms, the simplest and most abundant element in the cosmos, are crushed together. They overcome their natural repulsion and merge to form the next heaviest element, helium. This act of transformation, this forging of a new element, does not conserve all the original mass. A tiny fraction of it is converted directly into a tremendous burst of pure energy, as described by Albert Einstein's famous equation, E equals mc squared. This is the source of the sun's light and heat. Every second, the sun converts about 4 million tons of its own matter into energy, a continuous and silent act of self-sacrifice. It is a slow, steady consumption of its own being that will continue for another 5 billion years. This process is the engine of our world, the silent force that drives our weather, that feeds our plants through photosynthesis, and that ultimately powers our own bodies. To feel the warmth of the sun on your skin is to feel the distant, silent echo of this nuclear forge. To be touched by energy that was once the very substance of a star, a quiet reminder that we are intimately and profoundly connected to the great cosmic processes that unfold in the silent depths of space. The journey of that energy, from the sun's core to its surface, is a story of incredible patience. A photon of light, the very particle that will one day reach your eye, is born in the fury of a fusion reaction, but it does not travel in a straight line. The sun's interior is so incredibly dense, a sea of plasma packed tighter than stone, that the newborn photon can only travel a tiny fraction of a millimeter before it is absorbed by a particle and then re-emitted in a completely random direction. It zigzags, stumbles, and bounces its way through the solar interior in a journey called the random walk. For tens of thousands, or even hundreds of thousands of years, a single photon is trapped in this silent, chaotic dance, slowly making its way outward. This long, silent journey through the dense heart of its parent star is a meditation on perseverance. Then, finally, it reaches the sun's surface, the photosphere, and its journey changes. It is now free. It bursts forth and travels in a perfectly straight line through the vacuum of space, its long imprisonment over. In just 8.5 minutes, it silently crosses the vast distance to Earth, ending its epic journey by warming a leaf, glinting off the ocean, or entering your eye. The light that you see is ancient, born in a different millennium, carrying a story of a long, silent struggle and a final, glorious release. But the sun's influence is not limited to the light it sheds. It also constantly exhales a continuous, silent stream of charged particles into space, a flow of protons and electrons known as the solar wind. This is not a wind in the earthly sense. It is not the movement of air, but rather a tenuous plasma that blows outwards from the sun's corona at speeds of over 1,000,000 kilometers per hour. It flows past every planet, a constant and invisible river of matter that fills the entire solar system. This silent wind is so powerful that it carves out a vast bubble in the interstellar medium, the thin gas that exists between the stars. This protective bubble is called the heliosphere, and our entire solar system, out to its farthest reaches, resides inside of it. The heliosphere acts as a silent shield, deflecting many of the high-energy cosmic rays from deep space that would otherwise be harmful to life on Earth. We live and breathe inside this silent, protective sphere created by our star's unceasing breath. It is a quiet, invisible embrace, a cosmic womb that shelters us from the harsher realities of the galaxy. The sun, therefore, is not just a distant fire. It is the center and creator of our home, a silent provider of light, warmth, and protection. Its steady, quiet presence, the very definition of life in our small corner of the universe. The sun's steady, quiet presence defines the very nature of life in our small corner of the universe, creating a sheltered bubble within which the planets perform their slow and silent dance. But our solar system is not an entirely isolated kingdom. Its borders are sometimes crossed by ancient and mysterious travelers, silent wanderers that journey from the cold, dark frontiers. These are the comets and asteroids, messengers of ice and stone, carrying with them the pristine, frozen memories of our solar system's birth. They are not like the planets, which have been churned by geology and baked by the sun for eons. These are the leftover building blocks, the cosmic debris that never coalesced into a world. To look upon a comet, with its ghostly glowing tail, is to see a relic from 4.6 billion years in the past, a silent witness to the dawn of our own sun. Asteroids are primarily composed of rock and metal, the dense and durable materials that formed closer to the sun's heat, while comets are beautiful agglomerations of ice, dust, and frozen gases like carbon dioxide and methane, materials that could only have survived in the deep freeze of the outer solar system. They are time capsules, their chemistry almost perfectly preserved, and their silent passage through our neighborhood is a fleeting visit from a long-lost past, a whisper of our own origins. These silent messengers hail from two vast and distant realms that encircle our planetary system, like a great, dark forest. The closer of these is the Kuiper Belt, a wide, donut-shaped ring of icy bodies that begins just beyond the orbit of Neptune. This is the home of countless frozen worlds, including the dwarf planet Pluto, all orbiting in a slow, silent procession in the dim twilight of the sun's reach. But far beyond this, extending almost a quarter of the way to the nearest star, is the Oort cloud, a colossal, spherical shell of trillions of icy comets that envelops our entire solar system. It is a place of unimaginable cold and darkness, where the sun is just the brightest star in the sky, its gravitational hold so tenuous that the gentle nudge from a passing star can be enough to dislodge a comet from its ancient slumber. This is where our journey begins, with a single piece of ice and rock, disturbed from its orbit after billions of years of silent waiting. It begins to fall, a long, slow, and lonely descent toward the distant, beckoning sun. A journey that can take millions of years to complete, a silent pilgrimage from the edge of the sun's dominion to its very heart. As the comet continues its silent, inward journey, crossing the orbits of the outer planets, it remains a simple, dark chunk of ice and rock, indistinguishable from an asteroid. For thousands of years it falls, a dark stone in the dark, its approach unnoticed. But as it crosses the orbit of Jupiter and moves closer to the sun, a magical and silent transformation begins. The faint warmth of the distant sun begins to heat its frozen surface. In the airless vacuum of space, the ice does not melt into water. Instead, it undergoes a process called sublimation, turning directly from a solid into a gas. The silent, frozen world awakens. Jets of gas and dust erupt from its surface, creating a vast, glowing cloud around the nucleus, a temporary atmosphere called the coma, which can grow to be larger than a planet. This is the head of the comet we see, a fuzzy, luminous ball, all created by the silent power of sunlight on ancient ice. It is a beautiful and poignant process. The comet is sacrificing its own substance to create this fleeting spectacle, a brief and glorious moment of luminescence after an eternity spent in darkness. It is a meditation on the transformative power of warmth and light, how even the most ancient and frozen things can be awakened into a new and beautiful form. And as the comet swings ever closer to the sun, The solar wind, that same silent stream of particles we discovered earlier, begins to push on the gas and dust of the coma. This gentle but persistent pressure sweeps the material away from the sun, forming the comet's most iconic feature: its long, ethereal tails. There are often two tails, a brighter, curving one made of dust that reflects sunlight, and a fainter, straighter one made of ionized gas that glows with its own pale blue light. These tails, which can stretch for millions of kilometers across the sky, are a silent testament to the sun's constant, invisible breath. They always point away from the sun, regardless of the comet's direction of travel, making them a celestial weather vane in the solar wind. To witness a comet in our night sky is to see a silent dance between ancient ice and the power of a star, a transient spectacle of breathtaking beauty. And after it swings around the sun and begins its long journey back to the outer darkness, it leaves behind a trail of dusty debris along its orbital path. When the Earth happens to pass through one of these trails, those tiny particles of dust burn up in our atmosphere, creating a meteor shower, a silent, beautiful cascade of falling stars. Each one is a final, fleeting farewell from a piece of an ancient visitor, a gentle reminder of the great, silent journeys that are constantly unfolding all around us. These gentle reminders, the great, silent journeys that are constantly unfolding all around us, invite our perspective to zoom ever outwards, beyond the fleeting passage of a single comet, beyond the familiar dance of our local planets. When we stand in a place far from the glow of city lights and cast our eyes towards the heavens on a clear, moonless night, we can see a faint, luminous band of light stretching across the entire arc of the sky. Our ancestors saw it as a celestial river, a path for the gods, a spine for the night. They called it the Milky Way. Today, we understand that this soft, ethereal glow is not a cloud or a river, but a direct, edge-on view of our own home galaxy, a vast, rotating city of stars, so immense and so distant that the light of its countless individual suns all blends together into a single, silent, luminous stream. To gaze upon the Milky Way is to see our home, not from the outside, but from within our own quiet neighborhood, looking across the vast boulevards of stars towards the glowing downtown district of the galactic core. It is a profoundly humbling and peaceful experience, a visual confirmation of our place within something immeasurably vast and beautiful. A silent, stellar metropolis that we are an inextricable part of. This stellar city has a specific and elegant structure. Our Milky Way is a barred spiral galaxy, a cosmic pinwheel of breathtaking scale. At its center is a dense, bright bulge of older, golden-hued stars, through which runs a straight, bar-like structure. From the ends of this bar, several major spiral arms gracefully curve outwards, great, sweeping lanes of stars, gas, and dust that wind their way through the galactic disk. Our own sun, along with its family of planets, resides in a smaller, minor spur called the Orion Arm, about 2/3 of the way out from the galactic center. We are living in the quiet suburbs of this grand city. The arms themselves are not solid structures, but rather density waves, slow-moving, spiral-shaped traffic jams of celestial material. As clouds of gas and dust drift through the galaxy, they encounter these slow-moving arms and are compressed, triggering furious bursts of new star formation, which is why the spiral arms are so bright and studded with brilliant, young, blue stars. To visualize our place is to find a sense of peace in our quiet location, nestled within this vast, turning structure, far from the chaotic energies of the core, in a place calm enough for life to gently unfold. We are adrift in a silent, luminous river, part of its slow and majestic current. At the very center of this swirling city, at the heart of our galaxy, lies a silent and unseen anchor, a supermassive black hole named Sagittarius A star. Its mass is more than 4 million times that of our Sun, all condensed into a region smaller than the orbit of Mercury. We cannot see it directly, for not even light can escape its gravitational pull, but we can see its effects. We can watch stars in its immediate vicinity, whipping around in their orbits at incredible speeds, tracing paths that betray the presence of an immense, invisible mass. This is not a monster, not a cosmic vacuum cleaner devouring the galaxy, but rather the quiet, gravitational heart around which everything else revolves. It is the silent, heavy seed around which the Milky Way first coalesced, a point of extreme density that holds the entire structure of 100 billion stars together in a gentle, gravitational embrace. Its presence is a meditation on the unseen forces that create order and structure, a reminder that the most powerful and influential objects in the universe can also be the most silent and unobtrusive, their existence known only by the graceful dance they inspire in everything around them. This graceful, galactic dance occurs on a timescale so vast it quiets the mind. Just as the Earth orbits the Sun once a year, our entire solar system is also in orbit around the center of the Milky Way, but the journey is incomprehensibly long. It takes our Sun approximately 230 million Earth years to complete a single circuit, a period of time known as one galactic year. The last time our solar system was in this same position in the galaxy, the first dinosaurs were just beginning to walk the Earth. The time before that, the planet was covered in vast, primordial forests that would one day become coal. All of human history, from our earliest ancestors to this very moment, has taken place in a tiny fraction of a single galactic year. To contemplate this immense, silent rotation is to feel the hurried pace of our own lives dissolve into a deeper, slower rhythm. It places our worries and our triumphs into a vast, peaceful context, suggesting that we are part of a journey that is ancient, patient, and enduring. We are passengers on a celestial carousel, part of a silent, collective movement of stars and worlds, all turning together in the luminous, quiet river of time. We are all passengers on a celestial carousel, part of a silent, collective movement of stars and worlds, all turning together in the luminous, quiet river of time. And as we drift along this cosmic river, within the graceful spiral arms of our galaxy, we find ourselves drawn to regions where the starlight seems to gather, where the darkness is punctuated by vast, glowing clouds of breathtaking color and form. These are the nebulae, the stellar nurseries of creation, the silent, gentle wombs of the cosmos, where new stars are being born right now. They are among the most beautiful objects in the universe, great, painterly swaths of gas and dust that look like cosmic watercolors splashed against the black canvas of space. We see the famous pillars of creation in the Eagle Nebula, vast columns of cool gas sculpted by the light of newborn stars, or the intricate, lace-like filaments of the Veil Nebula. From our distant perspective, they appear serene and unchanging, but they are in fact dynamic, active places of slow and patient creation, vast cathedrals of dust where the silent, patient work of gravity is gathering the raw materials for the next generation of suns. These beautiful glowing clouds are, at their heart, something much colder and darker. The raw material for starbirth is found in what are known as giant molecular clouds, colossal, sprawling structures of hydrogen gas and interstellar dust that are incredibly cold, just a few degrees above absolute zero. In this profound chill, atoms are able to slow down enough to clump together into molecules, primarily molecular hydrogen. These clouds are so vast and dense that they block the light from the stars behind them, making them appear as dark, empty patches in the sky, a hole in the fabric of the cosmos. Creation, it seems, does not begin in a flash of brilliant light, but in the cold, the dark, and the quiet. It begins with a slow, gentle gathering. Within these cold, dark clouds, gravity, the universe's silent sculptor, begins its patient work. It is not a dramatic or violent force here, but a subtle, persistent whisper, a gentle encouragement for the scattered molecules to draw a little closer together. Over millions of years, the densest pockets within the cloud begin to contract under their own weight, slowly, inexorably, pulling more and more material in, a silent, gravitational inhalation that marks the very first step in the birth of a star. As we witness this slow, creative process, we come to understand why nebulae appear in so many different forms. Their beauty, a direct result of their interaction with starlight. Some are emission nebulae, where young, hot, newly formed stars are embedded within the gas cloud. The powerful ultraviolet radiation from these stars heats the surrounding hydrogen gas, causing it to glow with a characteristic, beautiful reddish-pink light, a process similar to how a neon sign glows when electricity passes through it. The Great Orion Nebula is such a place, a luminous cosmic cavern lit from within by its stellar infants. Other clouds, which do not have stars inside them, may be situated near a bright star, and they shine as reflection nebulae. Their dust particles act like a cosmic fog, scattering the starlight and reflecting it towards us, typically with a serene and gentle blue hue. And then there are the dark nebulae, those cold molecular clouds that are not illuminated at all, which we see only as stark black silhouettes against the richer star fields of the Milky Way, like the famous Horsehead Nebula. Each type is a different chapter in the silent story of creation, a different mood in the cosmic landscape, from the brilliant celebration of birth to the quiet, dark anticipation of what is to come. As a clump of gas and dust within a molecular cloud continues its slow gravitational collapse, another fundamental law of the universe begins to silently assert itself: the conservation of angular momentum. The initial cloud, vast as it is, will have some tiny, almost imperceptible amount of rotation. As gravity pulls it inward, shrinking its size, this rotation must speed up, exactly like an ice skater pulling in their arms to spin faster. This increasing spin prevents the cloud from collapsing into a simple sphere. Instead, it flattens into a wide, rotating disk of material, with a dense, hot core forming at the center. This core is the protostar, the embryonic sun, not yet shining with the fire of nuclear fusion, but glowing with a dull red heat generated by the friction and pressure of its own collapse. The surrounding disk, the protoplanetary disk, is the birthplace of future planets, moons, and asteroids. This is how our own solar system began, as a silent, spinning disk of stardust and gas. To visualize this moment is to witness the universe's deep-seated tendency to create order and structure. From a vast, formless, and chaotic cloud, the silent laws of physics conjure a star and a system of worlds, a process of exquisite and gentle choreography, all culminating in the growing heat and pressure at the center of the disk, where a new light is about to be kindled in the silent darkness. A new light is about to be kindled in the silent darkness. The protostar at the heart of the spinning disk continues to gather material from its surroundings, its core growing ever denser, ever hotter, under the relentless, silent crush of its own gravity. For thousands of years this process continues, the embryonic star glowing with a dull, infrared heat, its destiny hanging in the balance. Then, a critical threshold is reached. The pressure and temperature at its very center become so extreme, reaching more than 10 million degrees Celsius, that a new and miraculous process ignites: nuclear fusion. Hydrogen atoms, the universe's most basic building blocks, begin to fuse together to form helium, releasing a tremendous amount of energy in a silent, sustained burst of light. This is the moment a star is truly born. The outward pressure of the energy generated by this new fusion furnace pushes against the inward pull of gravity, and for the first time, the star achieves a perfect and stable balance. This state, known as stellar equilibrium, is the defining characteristic of a star's long and peaceful adulthood. It will remain in this state of silent, graceful balance for millions, or even billions, of years, steadily converting hydrogen to helium in its core, shining with a constant and dependable light. This long, stable period is called the main sequence, and it is a meditation on the beauty of equilibrium, of finding a sustainable, peaceful middle way between opposing forces, a long and quiet life of purpose. The story of that long, quiet life is written from the very moment of a star's birth, its entire fate determined by a single factor: its initial mass. The more massive a star is, the more gravity it has, which means its core must burn hotter and faster to maintain equilibrium. This means that the most massive stars, brilliant blue giants, hundreds of times the mass of our Sun, are also the most short-lived. They burn through their vast reserves of fuel in just a few million years, living fast and dying young in spectacular fashion. In contrast, the least massive stars, faint red dwarfs less than half the mass of our Sun, are incredibly frugal with their fuel. They sip at their hydrogen reserves so slowly that they can shine with a steady, dim light for trillions of years, far longer than the current age of the universe. Our own sun is a medium-mass, yellow star, with a total lifespan of about 10 billion years, a quiet and respectable middle-class existence in the grand cosmic scheme. This concept of a predetermined stellar evolution is a quiet lesson in the nature of things. Each star has its own path, its own silent story to live out, its character and its destiny woven into the very fabric of its being from the start. It is a reminder that everything in the universe follows its own nature, its own timeline, and that there is a unique and quiet beauty in every different path. For a star like our Sun, its long, peaceful life on the main sequence will last for another 5 billion years. But eventually, the hydrogen fuel in its core will run out. When this happens, the silent, elegant balance of stellar equilibrium is broken. With the outward push of fusion diminished, gravity will once again take over, and the star's core will begin to collapse. This collapse will raise the temperature even higher, igniting the remaining hydrogen in a shell around the core and causing the star's outer layers to expand dramatically. The Sun will swell into a red giant, its atmosphere expanding to engulf the orbits of Mercury and Venus, and perhaps even the Earth. After this dramatic but silent expansion, the dying star will finally begin to pulse, gently pushing its outer layers away into space. This expanding shell of luminous gas, illuminated by the hot, tiny core left behind, forms one of the most beautiful objects in the cosmos. A planetary nebula. It has nothing to do with planets. It was simply misnamed by early astronomers. It is a star's final, silent sigh, a gentle and graceful release of its being back into the cosmos. The glowing rings and intricate, butterfly-like shapes of these nebulae are a star's ghost, a fleeting, beautiful monument to a life lived in quiet service to the light. The fate of the most massive stars is far more dramatic. When they exhaust their fuel, the collapse of their immense iron core is so rapid and so catastrophic that it triggers a titanic explosion known as a Type II supernova. In a fraction of a second, the star releases more energy than our Sun will in its entire 10 billion year lifetime. For a few short weeks, a single exploding star can outshine its entire home galaxy of 100 billion stars. And yet, for all its unimaginable power and brilliance, this entire event unfolds in the perfect silence of the vacuum. It is a silent flash of light of cosmic proportions, a final, brilliant shout that is never heard. But this silent explosion is not just an act of destruction, it is a profound act of creation. The extreme temperatures and pressures in a supernova are the only places in the universe where the heaviest elements, like gold, platinum, and uranium, can be forged. The explosion then blasts these newly created elements, along with all the lighter elements the star created in its lifetime, far out into space. This stardust, enriched with the building blocks of life and worlds, will mix with the interstellar gas clouds, waiting to be gathered up by gravity once more, to form a new generation of stars and new planets. The silent death of one star is the necessary, generous, and beautiful precondition for the birth of countless others. The silent death of one star is the necessary, generous, and beautiful precondition for the birth of countless others. Its enriched stardust scattered into the void to begin the cycle anew. But in the immediate, silent aftermath of that colossal supernova explosion, something remarkable can be left behind at the very heart of the chaos. As the star's outer layers were blasted into space, its core was undergoing an equally dramatic, but opposite, process. A catastrophic implosion. For a star between about 8 and 20 times the mass of our Sun, the inward crush of gravity during the explosion is so immense that it overcomes the normal forces that keep atoms apart. Electrons are violently forced into the atomic nuclei, where they merge with protons to form a sea of pure neutrons. The entire core, once thousands of kilometers wide, collapses in a fraction of a second into an object of almost unimaginable density, a neutron star. This collapse is only halted by a powerful quantum mechanical principle called neutron degeneracy pressure, a fundamental rule of the universe that states that these newly formed neutrons cannot be packed any more tightly together. They resist any further compression with an incredible force, creating a new and final state of equilibrium. It is a star's essence, its very core, compressed into its ultimate, unbreakable form, a silent monument to the power of gravity and the deep resilience of matter. The physical properties of this stellar remnant are so extreme they defy our everyday intuition and quiet the mind with their strangeness. A typical neutron star, despite containing more mass than our entire Sun, is only about 20 to 30 kilometers in diameter, roughly the size of a single city. A single teaspoon of its material would have a mass of over 1 billion tons, as much as a mountain, or all of humanity combined. Its surface is unbelievably smooth, its immense gravity crushing any surface features down to microscopic heights, and it is trillions of times more rigid than steel. This is matter at the very edge of existence, pushed to the absolute limit of what is possible before it collapses entirely. To contemplate this extreme density is to meditate on the vast potential hidden within the fabric of the universe, the strange and wonderful forms that matter can take under the silent, relentless pressure of gravity. It is a physical reality so far removed from our own that it becomes an object of pure awe, a tiny, silent sphere containing the ghost of a sun, a cosmic diamond forged in the silent fire of a star's death. But this object is not just a static, silent sphere. The original star from which it was born was rotating, and just as a spinning ice skater pulls in her arms to spin faster, the conservation of angular momentum dictates that as the star's core collapsed, its rotation speed increased dramatically. Neutron stars are born, spinning incredibly fast, some rotating hundreds of times every second. Furthermore, the original star's magnetic field was also carried inward and compressed, becoming astoundingly powerful, trillions of times stronger than Earth's magnetic field. This combination of rapid rotation and an intense magnetic field turns the silent neutron star into a cosmic dynamo, a celestial engine of immense power. It generates powerful beams of electromagnetic radiation, including radio waves, that emanate from its magnetic poles. As the star spins, these beams sweep through space, like the beam of a lighthouse. If one of these beams happens to sweep across the Earth, our radio telescopes will detect a regular, rhythmic pulse. For this reason, we call such an object a pulsar. It is the universe's most accurate clock, a silent, spinning top whose rhythmic flash is a lonely, steady heartbeat in the vast, quiet expanse of the galaxy. This rhythmic pulse is not a sound, but a silent flash of energy, generated by a process known as synchrotron radiation. The intense magnetic field of the pulsar traps charged particles, like electrons, and whips them around at nearly the speed of light. As these particles are forced to spiral along the magnetic field lines, they release a continuous stream of energy in the form of a tight, focused beam. This is the lighthouse beam that we observe, a constant, silent scream of energy that we only perceive as a pulse because of the star's rotation. The pulsar is, in a sense, a ghost. It is not alive, for its nuclear fires have long since died. Yet, it is incredibly dynamic, radiating away its immense rotational energy into space over millions of years, slowly, silently, spinning down. It is a strange and beautiful afterlife for a star, a transformation from a steady, shining furnace into a rhythmic, flashing beacon. It is a meditation on the fact that even after a great and fiery end, a new kind of existence is possible, a different kind of life, one defined not by heat and light, but by a quiet, steady, and persistent rhythm that beats for eons in the silent dark. This quiet, steady, and persistent rhythm beats for eons in the silent dark, a testament to the resilient core that can survive a star's demise. But what happens when the original star is even more massive? What happens when it is so large, perhaps more than 25 times the mass of our Sun, that at the moment of its death, its gravity is simply overwhelming? In this ultimate cosmic scenario, nothing in the universe is strong enough to halt the collapse. Not the repulsion between atoms, not even the powerful neutron degeneracy pressure that forges a neutron star. Gravity, the silent, patient force that gathers stars from dust, wins completely and irrevocably. The collapsing core continues to shrink, past the density of a neutron star, past any known physical limit, until all its immense mass is crushed into an infinitely dense point, a singularity. At this moment, the object has so much gravity and curves the very fabric of its local universe so steeply that it effectively leaves our familiar reality behind. It creates a black hole, the universe's ultimate expression of silence and mystery, an object from which nothing, not even light, can escape. To better understand this gentle yet absolute tyranny, we must let go of the idea of gravity as a force that pulls, and instead embrace Einstein's more profound vision of gravity as a curvature in the fabric of space-time. Imagine space-time as a vast, flat, flexible rubber sheet. A planet like the Earth places a small dip in this sheet, and other objects, like the Moon, roll around in this dip, which we perceive as an orbit. A star creates a deeper dip. A neutron star creates a well so deep and steep that it is hard to climb out of. But a black hole is not just a deep well. It is a bottomless pit, a puncture in the fabric itself. It is a region where space-time is flowing inwards, like a river approaching a colossal waterfall. And the flow is so fast that it exceeds the speed of light. The black hole is not a hungry monster actively pulling things in, but rather a passive feature of the cosmic landscape, a place where the current of space itself has become an irresistible and silent torrent. To approach a black hole is to simply enter a part of the universe where all paths, all possible futures, lead in only one direction: inward. This silent, inward flow of space-time creates a boundary of profound significance, a threshold of no return, known as the event horizon. This is not a physical surface you could touch or see. It is a purely geometric boundary in space. It is the precise point in the river of space-time where the inward current becomes faster than the maximum possible speed of any object, the speed of light. Outside the event horizon, if you have a powerful enough rocket, you could still escape the black hole's gravity. But once you cross that invisible line, escape is impossible, not because you lack power, but because the space ahead of you is literally flowing inward, faster than you can move outward. The event horizon is the ultimate silence. Any event that occurs inside it is forever cut off from the rest of the universe. No light, no information, no signal of any kind can ever emerge from within its boundary, its story forever hidden from our view. It is a place of absolute quiet, a cosmic veil that separates the known from the unknowable, inviting a state of peaceful acceptance of the universe's greatest mysteries. And yet, though it is the embodiment of darkness, a black hole can create spectacular displays of light in the space around it, a silent testament to its presence. Just as a glass lens can bend and focus light, the immense gravity of a black hole can bend the path of light from distant stars that passes nearby. This effect, known as gravitational lensing, can distort the images of background galaxies, stretching them into arcs, or even creating multiple images of the same object. If a star is perfectly aligned behind a black hole, its light can be smeared into a perfect, ethereal circle, a beautiful and silent halo of light known as an Einstein ring. In this way, the black hole allows us to see it, not by what it emits, but by its silent, powerful influence on the light that journeys near it. And perhaps even these silent giants are not eternal. According to a theory by Stephen Hawking, due to subtle quantum effects near the event horizon, black holes may very slowly, over unimaginable timescales, radiate away their energy and mass. This Hawking radiation would be a faint, silent thermal glow, an incredibly slow evaporation. This suggests that even the most permanent and inescapable objects in the universe may eventually dissolve back into the quiet void, reminding us that all things are part of a vast, silent, and unending cycle of creation and return. Even the most permanent and inescapable objects in the universe may eventually dissolve back into the quiet void, reminding us that all things are part of a vast, silent, and unending cycle of creation and return. This cosmic cycle unfolds on scales that dwarf the lives of individual stars and even black holes. Just as we have zoomed out from planets to stars, we now gently pull our awareness back even further, to see the great star cities themselves, the galaxies, as the principal actors on the cosmic stage. And we find that these immense, silent islands of light are not solitary. They too are governed by the gentle, persistent whisper of gravity, and over the course of eons, they are drawn towards one another in a slow, majestic, and silent dance of cosmic proportions. On these scales, gravity inspires a process known as galactic cannibalism, a term that sounds violent, but is in reality a slow, graceful, and creative act of merging. Larger galaxies, like our own Milky Way, have grown to their current size by slowly and silently absorbing smaller, dwarf galaxies that stray too close. Over hundreds of millions of years, the smaller galaxy is gently pulled apart by the larger one's gravity, its stars spilling into the new host in long, beautiful streams, a quiet assimilation that adds to the richness and diversity of the larger whole. It is a meditation on how systems grow and evolve, not through conflict, but through a slow, silent embrace and integration. When two large galaxies of roughly equal size are set on a collision course, the result is one of the most spectacular and silent events in the universe. We can see this process happening right now in distant parts of the cosmos, in objects like the antennae galaxies or the mice galaxies. We see two great pinwheels of stars, gas, and dust beginning to interpenetrate, their structures distorted by their mutual gravitational pull. As they pass through one another, a beautiful and complex dance unfolds. Long, elegant streams of stars and gas are thrown far out into intergalactic space, creating what are known as tidal tails. These luminous arcs, stretching for hundreds of thousands of light years, are a silent, visual record of the galaxy's gravitational interaction, like the lingering ripples from two stones dropped into a perfectly still, cosmic pond. And though we call it a collision, the stars themselves almost never collide. The distances between individual stars are so unimaginably vast that when two galaxies merge, their stellar populations simply pass through each other, like two ghosts, their paths altered by gravity, but their physical forms remaining intact. It is not a crash, but a slow and graceful intermingling, a silent merging of two great rivers of stars into one. This silent merger is not just a rearrangement of existing stars, it is also a profoundly creative event. The galaxies are not just made of stars, they are also rich with vast, cold clouds of interstellar gas, the raw material for future star formation. As the two galaxies collide and their gas clouds smash into one another, the gas is compressed and shocked, triggering a colossal and galaxy-wide burst of star formation. This is known as a starburst galaxy. For a period of a few 100 million years, new stars are born at a furious rate, hundreds of times faster than in a quiet galaxy like our own. The entire merging system glows with the brilliant blue light of millions of newborn, massive stars, a silent and spectacular celebration of cosmic renewal. The merger, which at first seemed like a destructive event, is revealed to be a powerful engine of creation, a process that awakens the dormant potential of the galactic gas clouds and transforms them into a new generation of suns. It is a quiet reminder that moments of great change and upheaval, moments where different worlds and systems merge, can also be moments of the greatest creativity and new beginnings. This silent, creative future is not just a distant cosmic spectacle, it is our own destiny. Our Milky Way galaxy is currently on a collision course with our nearest large neighbour, the Andromeda galaxy. Andromeda is about 2.5 million light-years away, but it is approaching us at a speed of over 100 kilometers per second. There is no cause for alarm, as this grand, silent merger will not begin for another 4.5 billion years. When it does, our distant descendants, should they exist, will witness a night sky of unimaginable beauty. The familiar band of the Milky Way will be joined by the great, swirling disk of Andromeda, the two galaxies stretching across the heavens as they begin their slow, gravitational embrace. Over hundreds of millions of years, they will pass through each other, creating spectacular tidal tails and triggering a brilliant starburst that will light up the cosmos. Eventually, after a long and silent dance, the two spiral galaxies will settle down and merge into a single, larger, more spherical galaxy, which some astronomers have already nicknamed Milkomeda. It is a peaceful, beautiful, and creative fate, a silent promise that our own cosmic story is leading not to an end, but to a slow and graceful transformation into something new, something larger, and something even more magnificent. This slow and graceful transformation into something new, something larger, and something even more magnificent is the fundamental story of cosmic evolution. We see that galaxies are not isolated islands, but are in fact social and interactive, their mergers and groupings building ever larger structures. And so, with our perspective now accustomed to these immense scales, we can pull our awareness back one final time to view the entire observable universe all at once. When we do, we discover the most profound and beautiful silence of all. The silence of a hidden, underlying order. When we map the positions of millions of galaxies in three-dimensional space, we find that they are not scattered randomly, like seeds thrown to the wind. Instead, they are arranged in a vast and intricate pattern of unimaginable scale, a silent, luminous lacework that fills the entire cosmos. This grand design is known to astronomers as the cosmic web, the largest known structure in the universe. To gaze upon a map of this web is to witness the universe's silent architecture, a blueprint that reveals a deep and unexpected coherence, a quiet sense of order and belonging that spans all of existence. This cosmic web is best described through analogy. It is like a cosmic sponge, full of interconnected structures and empty voids. Or perhaps, more poetically, it is like the neural network of a cosmic brain, with long, glowing filaments of galaxies connecting at dense nodes, like synapses firing with the light of 1 trillion suns. These are the two primary components of the web. The first are the galaxy filaments and superclusters, the bright, luminous threads of the cosmic tapestry. These are vast, rope-like structures, hundreds of millions of light-years in length, along which galaxies and galaxy clusters are arranged like pearls on a string. Our own Milky Way galaxy resides within a filament that is part of the Laniakea supercluster, a Hawaiian name meaning immeasurable heaven. To know our cosmic address is to know that we are not adrift in a random chaos, but a part of a specific filament, a particular thread in this great, silent, and interconnected structure. It fosters a sense of being part of a larger whole, a quiet feeling of being exactly where we are supposed to be, woven into the very fabric of the cosmos. The second, and equally important, component of this grand structure is defined by its absence. Between the luminous, galaxy-rich filaments lie the great cosmic voids. These are colossal, almost perfectly empty regions of space, vast, dark, and silent bubbles that can be hundreds of millions of light-years across. While the filaments are bustling with the light and gravity of countless galaxies, the voids are places of profound peace and emptiness. They are not entirely empty. They are sparsely populated by a few lonely galaxies, and filled with a tenuous, phantom mist of dark matter and primordial gas. But for the most part, they are the great quiet places of the universe. The existence of these voids is a meditation on the importance of emptiness, of the silence that exists between the notes of a symphony. The beautiful, luminous structure of the filaments is only made meaningful by the deep, dark, and silent voids that surround them. They are a cosmic expression of yin and yang, the interplay between presence and absence, matter and emptiness, that gives the universe its shape, its texture, and its profound, silent beauty. To find peace, we can imagine our minds resting not in the busy filaments of thought, but in these calm, empty, and silent cosmic voids. This entire, majestic structure, this silent web of light and shadow, was not built by a cosmic architect, but was sculpted patiently and silently by the hand of gravity over the entire age of the universe. In the very first moments after the Big Bang, the universe was an almost perfectly smooth, uniform soup of energy and matter. But there were tiny, microscopic, quantum fluctuations in its density, regions that were infinitesimally denser than others. As the universe expanded and cooled, gravity, the ever-patient force, began to work on these tiny seeds. The slightly denser regions exerted a slightly stronger gravitational pull, silently drawing in matter from the surrounding, less dense regions. Over 13.8 billion years, this slow, silent process amplified those initial, tiny fluctuations into the colossal structures we see today. The denser regions became the filaments and superclusters, and the less dense regions, having had their matter silently stolen away, became the great cosmic voids. The cosmic web is, therefore, a fossil, a silent, magnificent record of the universe's earliest moments, a beautiful and humbling reminder that the grandest and most complex structures can arise from the smallest, quietest, and most humble of beginnings. The cosmic web is a silent, magnificent record of the universe's earliest moments, a beautiful and humbling reminder that the grandest and most complex structures can arise from the smallest, quietest, and most humble of beginnings, all sculpted by the patient hand of gravity. Yet, as we gaze in awe at this cosmic architecture, a profound and quiet mystery begins to dawn upon us. When astronomers calculate the total mass of all the visible matter in the universe, all the stars, all the gas, all the dust in all the hundreds of billions of galaxies, they find that it is not nearly enough. The gravitational force produced by the matter we can see is a mere fraction of what would be needed to herd galaxies into such vast filaments and to hold them together against the expansion of the universe. The luminous web we observe is being sculpted and held in place by a form of gravity whose source is completely invisible to us. It is as if we are watching a grand celestial dance, but can only see a few of the dancers, their movements clearly being influenced by a vast unseen crowd. This invisible presence, this silent majority of the cosmos, has been given a simple and mysterious name: dark matter. It is the quiet, unseen scaffolding upon which the entire luminous universe has been built. Our first clue to this silent presence came not from the grand scale of the cosmos, but from the gentle, spinning motion of individual galaxies. According to our understanding of gravity, stars in a galaxy should orbit the center, much like planets orbit the sun. The farther out a star is, the slower it should be moving. But when astronomers like Vera Rubin first carefully measured these galactic rotation curves in the 1970s, they found something completely unexpected. The stars on the outer edges of galaxies were moving just as fast as the stars closer in, and in some cases, even faster. This is impossible, unless the galaxy contained far more mass than could be accounted for by its visible stars. The stars were moving as if they were embedded in a vast, invisible halo of matter, its gravitational pull holding them in their rapid orbits and preventing them from flying off into the void. This was the first quiet whisper of a profound truth, that the beautiful, spinning disks of stars we see are just the luminous tip of a much larger and more massive iceberg, a silent, spherical halo of dark matter that extends far beyond the visible light. It is a deeply humbling discovery, a quiet reminder that what we can see with our eyes is not all that there is, and that we are surrounded by a vast, unseen reality whose silent presence shapes the world we know. We can now map this unseen reality, not by seeing the dark matter itself, but by observing its silent influence on the light that travels through it. As we have learned, mass curves space-time, and this curvature bends the path of light, an effect known as gravitational lensing. Because dark matter has mass, it too bends space-time. By observing distant galaxies, astronomers can see how their light is subtly distorted and bent as it passes through the vast stretches of space on its journey to us. If there is a large, unseen concentration of dark matter, such as a dark matter halo surrounding a cluster of galaxies, it will act like a giant, invisible lens, creating beautiful arcs and smeared images of the galaxies that lie behind it. By carefully measuring these tiny distortions across the entire sky, scientists can create a map, a silhouette, of the invisible. They can trace the unseen filaments and nodes of the cosmic web, revealing the hidden gravitational landscape that underpins the visible universe. It is a beautiful and subtle form of observation, a way of seeing not with light, but with the silent language of gravity, a way of knowing a thing is there simply by the gentle and persistent way it shapes everything around it. So what is this strange, silent substance? The honest answer is that we do not yet know for sure. But we know what it is not. It is not made of the same particles as us. It is not made of protons, neutrons, and electrons, what scientists call baryonic matter. If it were, it would interact with light in some way, It would absorb it, or reflect it, or emit it. But dark matter does none of these things. It appears to be a completely new type of particle, something outside our current standard model of physics, that feels the force of gravity, but is almost completely immune to all other forces, including the electromagnetic force that governs light. It is silent and transparent, a cosmic ghost that passes through our bodies, through the earth, and through the stars, as if they were not even there. Its only interaction with our world is its collective, gentle, and persistent gravitational pull. This is why it was so essential for the formation of the universe. While normal matter was pushed around by the pressure of light in the early universe, dark matter, being immune to light, could begin to clump together much earlier, forming the first silent gravitational wells, the invisible scaffolding that would patiently wait for the visible matter to cool and settle into it, forming the galaxies and the cosmic web we see today. It is the universe's quiet and unseen partner, the silent architect whose invisible hand has shaped the cosmos into its current, magnificent form. Dark matter is the universe's quiet and unseen partner, the silent architect whose invisible hand has shaped the cosmos into its current, magnificent form. It provided the gravitational scaffolding, the hidden blueprint upon which the luminous structures of the universe were built. But if dark matter built the house, where did it get the architectural plans? To find them, we must journey back in time, further than any telescope can see, back to the very dawn of the universe itself. We must listen not for the light of stars or galaxies, but for the oldest, faintest, and most profound light in all of existence. This light is no longer visible to our eyes, for after travelling for nearly 14 billion years through an expanding universe, it has cooled and stretched into a faint, low-energy glow. It is the cosmic microwave background, the CMB, and it is the silent, residual heat from the creation of the universe, the afterglow of the Big Bang. This ancient light fills all of space. It comes to us from every direction, with almost perfect uniformity, a silent, omnipresent whisper of our cosmic origins. To understand this whisper, we must imagine the universe in its infancy. The Big Bang theory does not describe a bomb-like explosion in a pre-existing space, but rather the expansion of space itself from an initial state of unbelievable heat and density. In its first few 100,000 years, the entire universe was a hot, dense, and opaque fog. It was a searing plasma of fundamental particles, protons, neutrons, and electrons, all bathed in an intense, brilliant light of photons. In this primordial soup, the photons, the particles of light, were so energetic that they were constantly crashing into the electrons, scattering in all directions, unable to travel any significant distance. The universe was like the inside of a star, a place where light was trapped, unable to shine freely. But as the universe continued to expand, it also cooled, and when it was about 380,000 years old, it reached a critical, magic temperature of about 3,000 degrees Celsius. At this temperature, it was finally cool enough for the protons and electrons to slow down and combine to form the first stable, neutral hydrogen atoms. This moment is known as the era of recombination, and it was a moment of profound and universal clarification. With the free electrons now bound up inside atoms, the photons of light were suddenly liberated. For the first time, they could travel freely through the universe without immediately crashing into something. The cosmic fog lifted. The universe, in a single, silent moment, became transparent. The light that was released at that instant, from that surface of last scattering, has been travelling unimpeded through the cosmos ever since. This is the light that we now detect as the cosmic microwave background. As it has travelled, the universe has continued to expand, stretching the wavelength of this ancient light, cooling it from its initial brilliant orange-white glow down to the faint, cold microwave radiation we detect today, at a temperature of just 2.7 degrees above absolute zero. Its discovery in the 1960s was a profound confirmation of the Big Bang theory. It is like feeling the faint, residual warmth on the walls of a room from a fire that went out long ago. The CMB is the silent, thermal echo of creation, a baby picture of the entire cosmos at the moment it first became clear. And when we look at this baby picture with incredibly sensitive instruments, we discover something miraculous. The glow is not perfectly uniform. There are tiny, almost imperceptible variations in its temperature from one spot in the sky to another, minuscule fluctuations that are only about 1 part in 100,000. These are the gentle, silent ripples on the surface of the primordial fire. These tiny hot and cold spots in the CMB represent the very first structures in the universe, the regions that were infinitesimally denser or less dense than their surroundings in the initial cosmic soup. These are the architectural plans. These minuscule fluctuations, these quiet whispers of structure from the dawn of time, are the very seeds that gravity would later cultivate. The slightly denser, slightly cooler, blue-tinted spots on the CMB map were the places where there was just a little more matter, the places where the silent, gravitational pull would be just a little stronger. Over billions of years, the invisible hand of dark matter would amplify these tiny seeds, pulling more and more matter towards them, patiently sculpting them into the vast filaments, superclusters, and voids of the cosmic web we see today. Every galaxy, every star, every planet, and indeed, every one of us, can trace our origins back to one of these tiny, silent ripples in the very first light of the universe. Every galaxy, every star, every planet, and indeed, every one of us, can trace our origins back to one of these tiny, silent ripples in the very first light of the universe. A silent promise, whispered at the dawn of time. But a promise is not fulfilled in an instant. The journey from those faint, primordial seeds to the vast and intricate cosmic web of today was a pilgrimage of almost unimaginable length, a slow and patient unfolding that took place across a vast and silent ocean of time. We have journeyed through the immense distances of cosmic space, and now, as our journey begins to draw inward, we must turn our contemplation to the equally vast and silent abyss of cosmic time. Our own lives are measured in heartbeats, in sunrises, in the passing of seasons, a rhythm that feels immediate and pressing. But the universe operates on a completely different timescale, a slow, deep, and steady rhythm known as deep time. To find peace, we must allow our own hurried sense of time to dissolve into this much grander and more patient current, to feel our own brief existence as a precious and beautiful moment floating upon an ancient and unfathomable sea. The age of our universe, from the first moment of the Big Bang until now, is calculated to be approximately 13.8 billion years, a number so vast our minds can barely hold it. We know this not through guesswork, but through the patient work of science, by measuring the rate at which the universe is expanding and winding the clock backward, and by using the steady, silent decay of radioactive elements in the oldest meteorites, a process called radiometric dating, to find a consistent and beautiful cosmic story. To truly feel the scale of this deep time, to let its quiet immensity settle our minds, we can use a beautiful and humbling analogy, mapping the entire 13.8 billion year history of the universe onto a single, familiar calendar year. In this cosmic calendar, the Big Bang happens in the very first second of midnight on January 1st. For months, nothing we would recognize exists. The vast clouds of gas are just beginning to coalesce. Our own Milky Way galaxy does not begin to form until early May. For the entirety of the cosmic spring and early summer, our home is still being built. The Sun and its family of planets, including our own Earth, do not condense from their spinning cloud of stardust until early September. So, for the first 8 months of the cosmic year, our world did not even exist. Life on Earth ignites soon after, perhaps around late September, but for billions of years, it remains a simple, single-celled affair, a quiet and humble beginning in the planetary seas. The great flourishing of complex life, the Cambrian explosion, does not occur until mid-December. The age of the dinosaurs, which seems so ancient to us, spans only a few days around Christmas. When we look for ourselves in this vast, cosmic year, the experience is profoundly quieting. The first recognizable human ancestors do not appear on the scene until the evening of December 31st. All of recorded human history, every kingdom, every empire, every discovery, every war, every love story, every piece of art, Every single thing we have ever read about in our history books takes place in the last 10 seconds of the last minute of the last day of the year. The European Renaissance, a great flourishing of human creativity, is a single second. The average human life is but a fleeting fraction of a cosmic second. This perspective is not meant to make us feel small or insignificant, but rather to instill a sense of profound peace and wonder. It frees us from the tyranny of our own urgency. It suggests that the universe is in no hurry, that its creative process is one of immense patience and deliberation. Our anxieties and worries, which can feel so all-consuming in the moment, are placed in a context so vast that they can gently soften and dissolve. We are the fleeting but beautiful consciousness of the universe in its final moments of the year, a brief and precious opportunity for the cosmos to look back upon itself and to wonder. Our brief moment is not a flaw, it is a gift, a chance to witness this ancient and silent unfolding. And so, as you rest here, let your own sense of time expand. Let go of the calendar of your day, of your week, of your year. Let your awareness drift upon this deep, slow, and silent ocean of cosmic time. Feel the immense stillness that has existed for billions of years before you, and the equally vast stillness that will stretch for billions of years after you. Feel your own breath as a gentle rhythm within that greater, slower pulse. Every tick of the clock, every hurried appointment, every deadline is an invention of our own brief moment in the cosmic year. The universe itself knows only the slow, graceful, and silent transformation from one state to another, the patient turning of stardust into stars, of stars into planets, and of planets into the quiet, contemplating consciousness that is you, right here, right now. There is a deep and profound rest to be found in this perspective, a letting go of the struggle against time, and a gentle acceptance of our place within its vast, silent, and peaceful embrace. We find a gentle acceptance of our place within the vast, silent, and peaceful embrace of deep time, our fleeting moment of consciousness made all the more precious by its rarity. And as our minds settle into this quiet, cosmic perspective, a new and gentle question may begin to arise. It is a shift from the what and the how of the universe to the soft and wondrous why. Why is it that this universe, after 13.8 billion years of silent, patient unfolding, has produced a state of matter capable of contemplating it? Why is the cosmos not just a sterile, silent sea of gas and radiation, but a place that can give rise to stars, to planets, to life, and to minds? This is not a question with a simple answer, but the gentle exploration of it is a meditation in itself, a journey into one of the most profound and humbling ideas in all of science, the anthropic principle, and the quiet suggestion that our universe appears to be exquisitely and improbably fine-tuned for existence. Our journey begins with the quiet and mysterious bedrock of reality itself, the fundamental constants of nature. These are the handful of numbers that are woven into the very fabric of physics, defining the strength of all the forces and the properties of all the particles. There is the gravitational constant, often called g, which sets the strength of gravity. There is the speed of light, c, the ultimate speed limit. There is the charge of the electron and the mass of the proton. These numbers are not predicted by our theories, they are simply measured. They are the settings that our particular universe happens to have. And what we have discovered, in a finding that quiets the mind with its sheer improbability, is that the existence of a complex, life-giving universe is incredibly sensitive to the precise values of these constants. If any of them were changed by even a tiny, almost infinitesimal amount, the universe, as we know it, could not exist. The cosmos is balanced on a razor's edge, a silent, mathematical miracle of profound delicacy. Let us contemplate this fine-tuning with a few gentle examples. If the force of gravity were just a tiny bit stronger, stars would burn through their fuel much faster, shining so hot and so briefly that there would not be enough time for planets to form and for life to evolve around them. If gravity were just a tiny bit weaker, stars and galaxies might never have been able to form at all, the primordial gas clouds never gathering enough mass to ignite. The universe would have remained a thin, cold, and silent soup forever. Consider the strong nuclear force, the force that binds protons and neutrons together in an atomic nucleus. If it were just a few percent weaker, only hydrogen would be stable, no other elements could form, and the rich chemistry required for life would be impossible. If it were a few percent stronger, all the hydrogen in the early universe would have fused into heavier elements, leaving no fuel for long-lived stars like our Sun. The universe is a story of balance, a silent, cosmic negotiation between forces. And we exist within the breathtakingly narrow, habitable zone of these fundamental parameters. It is as if we have stumbled upon a universe with its dials tuned with impossible precision to the one station that plays the music of life. How do we sit with this profound and silent observation? One gentle philosophical approach is the weak anthropic principle. It suggests that there is no deep mystery here, but rather a simple selection effect. We should not be surprised to find ourselves living in a universe whose properties allow for life, because if the universe had different properties, we would not be here to observe it. We could only have arisen, and therefore can only ask the question, in a universe that is compatible with our own existence. It transforms the question from, why is the universe so perfectly tuned for us, to why are we so perfectly suited to our universe? It is a quiet, contemplative reversal that fosters a sense of belonging, a feeling that we are not strangers in the cosmos, but a natural and fitting expression of its fundamental laws. And this leads to another, even more mind-expanding thought. Perhaps our universe is not the only one. Perhaps there is a vast multiverse of other universes, each with its constants set to random values, like a radio scanning through all the frequencies. The vast majority of these universes would be sterile and silent, places where the physics does not allow for stars or chemistry. And we, by definition, simply find ourselves in one of the rare, beautiful, and life-giving ones. This is not a proven theory, but a quiet, awe-inspiring meditation, a way to appreciate the precious, improbable gift of our own silent, star-filled sky. We sit with this quiet, awe-inspiring meditation, appreciating the precious, improbable gift of our own silent, star-filled sky, a universe that appears perfectly suited for our existence. This deep sense of belonging, of being a natural expression of the cosmos, can be felt not just as a grand, philosophical idea, but as a direct, physical, and intimate truth. For the journey from the Big Bang to you is not just a story of physics and astronomy, it is your own personal, ancestral story. The very substance of your body, the atoms that form your bones, your muscles, your heart, and your mind were not created here on Earth. They are ancient travelers, forged in the hearts of long-dead stars and scattered across the galaxy in silent, brilliant explosions. The familiar phrase, "we are made of stardust," is not just poetry, it is a literal, scientific reality, a truth that bridges the unimaginable gulf between the human and the cosmic and brings the silence of space directly into the quiet sanctuary of your own being. Our story begins where the universe's story begins. In the immediate aftermath of the Big Bang, a process known as Big Bang nucleosynthesis created the very first atomic nuclei. But in that brief, hot, primordial era, only the very lightest and simplest elements could form. The early universe was almost entirely composed of hydrogen and helium, with just a tiny trace of lithium. There was no carbon, no oxygen, no nitrogen, no iron, none of the heavier elements that are essential for the complex chemistry of life as we know it. The universe was born with a simple, clean slate, a silent, vast potential that had yet to be enriched with the ingredients necessary for worlds and for beings. For this, the universe needed to invent a new kind of creative engine, a new kind of silent, cosmic forge. It needed to invent stars. For hundreds of millions of years after the first light was released, the universe was filled with these vast, silent clouds of hydrogen and helium. Gravity slowly gathered them into the first stars, and it was inside the immense pressure and heat of these stellar cores that the next chapter of creation silently began. This process is called stellar nucleosynthesis. Stars are giant, stable fusion reactors. For billions of years, in their quiet and dependable lives, they fuse hydrogen into helium. But as they age and their cores grow hotter, they can begin to fuse helium into heavier elements. 3 helium nuclei can be fused into a single nucleus of carbon, the fundamental backbone of all life on Earth. A carbon nucleus can then capture another helium nucleus to become oxygen, the element that you are breathing in this very moment. A further fusion creates neon, and so on, with stars patiently and silently building up the periodic table, step by step, forging the raw materials of life in their fiery hearts. The carbon atoms in your very cells, the oxygen that fills your lungs with each quiet breath, the nitrogen in your DNA, all of it was created inside a star that lived and died long before our own sun was ever born. But this stellar forging has its limits. The process of fusion inside a star's core can only create elements up to iron. To create the elements heavier than iron, like the copper in our wires, the silver and gold in our jewelry, or the iodine that is vital for our health, the universe requires an even more spectacular and powerful event. It requires the silent, catastrophic death of a massive star in a supernova explosion. In that final, brilliant, and silent flash, the temperatures and pressures become so extreme that a rapid-fire series of nuclear reactions forges all the remaining elements of the periodic table in a matter of seconds. Let us, for a moment, follow the journey of a single iron atom, an atom that may, at this very moment, reside within a red blood cell, carrying oxygen through your body. Its story began in the core of a star perhaps 50 times the mass of our Sun. For millions of years, it was part of a stable, stellar furnace. Then, the star died. In a silent, titanic explosion, our iron atom was violently thrown out into the interstellar medium, beginning a lonely journey through the silent void of the galaxy that would last for millions, or perhaps billions of years. It drifted through beautiful nebulae. It was pushed by the gentle pressure of starlight and the silent solar winds of other stars. Eventually, it found itself part of a cold, dark, molecular cloud, that same kind of cloud that we know is a stellar nursery. And within that cloud, a new star began to form, our Sun. Our iron atom was swept up, not into the star itself, but into the spinning protoplanetary disk that surrounded it. Here, it became part of a small rocky planet, the Earth, buried deep within its molten core for a time, then brought to the surface through volcanic activity. It rested in a rock for millennia, was weathered by the silent action of rain and wind, was absorbed into the soil, taken up by the roots of a plant, eaten by an animal, and finally found its way into you. You are a repository of cosmic history, a quiet, living museum of the universe's creative power. You are not separate from the silence of space. You are its child, its descendant, its most intricate and beautiful creation. You are not separate from the silence of space. You are its child, its descendant, its most intricate and beautiful creation. A temporary and wondrous collection of stardust that has woken up. This profound and intimate connection to the cosmos, this realization that the universe seems to possess an inherent, creative impulse to forge the building blocks of life, naturally leads our quiet contemplation outward once more. If the laws of physics and chemistry that gave rise to us are the same everywhere, if the universe has been patiently creating the necessary elements for 13.8 billion years, and if there are billions of other galaxies, each containing billions of other stars, and likely trillions of other planets, then a gentle and logical question begins to form in the quiet of our minds. Where is everybody else? If the universe is a cosmic garden, are we its only flower? This question is the heart of a deep and poignant mystery known as the Fermi paradox, and it invites us to meditate upon the most profound silence of all, the great silence of a seemingly empty, yet potentially life-filled cosmos. To gently explore this question, we can consider a beautiful thought experiment first proposed by the astronomer Frank Drake. The Drake equation is not a rigid formula meant to produce a definitive answer, but rather a way of organizing our ignorance, a quiet, contemplative tool to help us think about the probability of finding other intelligent, communicative life in our galaxy. It does this by breaking the grand question down into a series of smaller, more manageable estimations. We start with the rate of star formation in our galaxy, and then we ask, what fraction of those stars have planets? Thanks to modern astronomy, we now know the answer is nearly all of them. Then we ask, what fraction of those planets might be in the habitable zone, the gentle region where liquid water could exist? And of those, on what fraction might life actually arise? And of those, what fraction might evolve intelligence? And of that intelligent life, what fraction might develop technology capable of sending signals into space? And finally, the most poignant question of all, for how long do such civilizations last? While the answers to most of these questions are complete unknowns, the simple act of contemplating them reveals the immense, silent potential of the cosmos. Even with the most conservative and pessimistic assumptions, the equation often suggests that our galaxy should be home to thousands, if not millions, of other civilizations. And this is the paradox. The logic suggests our galaxy should be teeming with life, a vibrant, noisy place, full of signals and activity. But when we look, and when we listen, all we perceive is a profound and unbroken silence. The sky is not full of alien radio broadcasts. We see no evidence of great, interstellar engineering projects. No starships have ever arrived at our shores. This stark and silent contradiction between the high probability of extraterrestrial life and the complete lack of any evidence for it is what gives the Fermi paradox its quiet and soulful power. It is a question that resonates deep within the human experience, the feeling of being alone in a vast and silent room, wondering if there is anyone else out there. The great silence is not a frightening or hostile silence, but a deep, mysterious, and perhaps even melancholy one. It invites us to hold two powerful ideas in our minds at once. The idea that we are cosmically connected to everything, made of the same stardust as the worlds around us, and the idea that we may be uniquely, profoundly alone. There are, of course, many gentle and contemplative possible solutions to this silent mystery. Perhaps they are grouped under the idea of a great filter, the hypothesis that there is some powerful, universal barrier that makes the emergence of a long-lasting, interstellar civilization incredibly rare. Perhaps the filter is behind us. Perhaps the initial leap from non-life to life is an event of such staggering improbability that it has only happened once, here on Earth. Or perhaps the filter lies ahead of us, a future challenge that all technological civilizations face, a silent hurdle that few, if any, ever manage to overcome. Other possibilities are less dramatic. Perhaps the distances are simply too vast, the galaxy too large for signals to have reached us yet. Perhaps intelligent life is abundant, but they are not interested in broadcasting, choosing instead to explore their own inner universes, or living quietly in harmony with their worlds. Perhaps they are communicating in ways we cannot yet comprehend, their whispers carried on neutrinos or gravitational waves, a language our technological ears are not yet built to hear. Or perhaps, in a profoundly humbling thought, they were here long ago, and we are just too young a species to have noticed the ancient, silent ruins they left behind. Our own small and beautiful effort to listen, the search for extraterrestrial intelligence, or SETI, is our quiet answer to this mystery. It is the act of pointing our radio telescopes at the silent stars and listening, patiently, for a single, structured signal, a whisper of intelligence in the great cosmic quiet. It is an expression of our deepest hope, our most profound curiosity, a silent vigil we keep for a family we have never met. It is an expression of our deepest hope, our most profound curiosity, a silent vigil we keep for a family we have never met. This act of quiet, patient listening, of turning our awareness towards the vast and silent unknown, is not just something we do with our telescopes. It is a fundamental human capacity, a deep and innate ability that we can practice at any moment. For the great, silent, and mysterious cosmos that stretches for billions of light years around us has a perfect and beautiful mirror, a reflection of its vastness, its complexity, and its silence that exists within the quiet darkness of your own skull. Our journey through the silence of space now takes its final and most intimate turn, a journey inward to explore the inner cosmos of the mind, and to discover that the same patterns, the same mysteries, and the same profound peace we have found in the stars can be found within the silent, intricate architecture of our own consciousness. Your brain, the physical seat of this inner universe, is the most complex object we have yet discovered anywhere in the cosmos. It contains approximately 86 billion neurons, specialized cells that act as the stars and galaxies of your inner world. Each of these neurons is connected to thousands of others, forming a network of literally trillions of connections, or synapses, a web of communication of almost unimaginable density and intricacy. When you think a thought, feel an emotion, or recall a memory, it is not a single neuron firing, but a vast and complex pattern of electrochemical signals, a silent, flickering cascade of light that ripples through this immense, living network. To visualize your own mind is to imagine a galaxy of thought, a universe of feeling, all contained within a space no bigger than your two hands, all operating in a profound and beautiful silence, a quiet, internal light show that is the very essence of you. And here, in this quiet inner world, we find the most breathtaking echo of the outer cosmos. When scientists create computer simulations of the formation of the universe, showing how dark matter and gravity sculpt the cosmic web over billions of years, the resulting image, that vast, filamentary, sponge-like structure of galaxies and voids, looks uncannily, astonishingly similar to the network of neurons in the human brain. The large-scale structure of the universe seems to follow the same silent, architectural principles as the structure of a thinking mind. This is not to say that the universe is a literal brain, but rather to suggest, in a gentle and awe-inspiring way, that the laws of physics and information give rise to similar, beautiful, and efficient patterns on vastly different scales. It is a quiet, visual mantra that whispers of a deep and profound unity in the nature of things. It suggests that your own mind is not an alien structure in a foreign universe, but a natural and fitting part of it, a small-scale reflection of the same silent, creative impulse that built the stars. Our perception of reality itself is a testament to the silent, creative power of this inner cosmos. The world you experience, the feeling of the sheets against your skin, the memory of a loved one's face, the very sense of being here, right now, are all constructed within this silent network. Your eyes do not see, they merely gather light. Your ears do not hear, they merely detect vibrations. This raw sensory data is transmitted as a stream of cold, silent, electrical signals to your brain. It is your brain that silently and seamlessly weaves these signals into the rich, colorful, and meaningful tapestry that you call reality. Your consciousness is a silent artist, a master weaver, creating your entire world from the silent threads of information. And just as we have meditated on the silent voids of the outer cosmos, we can find peace by turning our attention to the silent spaces within our own minds. This is the goal of deep meditation, or the natural state of deep, dreamless sleep. It is a journey into the quiet voids of our own inner web, a place where the constant chatter of the thinking mind, the busy filaments of thought, can finally come to rest. It is a state of pure being, of quiet, formless awareness, where the small, personal self can dissolve for a time into a greater, universal silence, a place of profound restoration, healing, and peace. We journey into this place of profound restoration, healing, and peace, realizing that the silence we have sought in the distant reaches of the cosmos has been waiting for us, patiently, within ourselves all along. Our long meditation is now complete. We have traveled together from the simple idea of a sound wave needing air to the perfect, silent vacuum of interplanetary space. We have rested our gaze upon the familiar, silent face of our moon, and we have followed the slow, gravitational dance of the planets as they circle the silent, life-giving fire of our sun. We have journeyed with ancient comets from the cold, dark edge of our solar system, and we have zoomed out to feel our own small and peaceful place within the luminous, turning river of the Milky Way. We have witnessed the gentle, silent birth of new stars in the cold dust of nebulae, and we have followed their long, quiet lives to their final, generous, and silent ends. We have felt the strange, rhythmic pulse of a distant pulsar, and we have stood at the quiet, mysterious edge of a black hole's event horizon, contemplating the silent flow of space-time itself. We have watched the slow, graceful embrace of galaxies merging over billions of years, and we have pulled our awareness back to see all of existence woven into the silent, beautiful architecture of the cosmic web. We have felt the unseen presence of the dark matter that holds it all together, and we have listened to the first silent whisper of creation in the ancient light of the cosmic microwave background. We have floated on the unfathomable, deep ocean of cosmic time, finding a sense of peace in our own brief and precious moment. We have marveled at the improbable, fine-tuned nature of a universe that is so exquisitely balanced for life, and we have brought this cosmic story into our own bodies, feeling the profound and literal truth that we are made of stardust. We have listened with hope and with wonder to the great, silent mystery of a quiet galaxy, and finally, we have brought our journey home, discovering a perfect mirror of the cosmos in the silent, intricate, and beautiful universe of our own mind. Through all of this, the silent laws of physics have been our guide, and we have perhaps come to see science not as a cold collection of facts, but as a form of deep and patient attention, a way of looking at the world with such quiet reverence and care that it reveals its most subtle and wondrous secrets. It is a practice of quieting our own assumptions and our own noise, so that we may hear the silent story the universe is always telling. And perhaps the deepest peace to be found in this long journey is in the gentle release of our need for the universe to have a loud and obvious purpose for us. The universe does not shout our meaning at us from the stars. Its silence may be its greatest gift. It offers us a vast, beautiful, and quiet canvas, and upon that canvas we are invited to paint our own meaning. We find it in the act of learning, in the feeling of awe, in the wonder of our own existence. We find it in the profound connection we feel when we realize that the iron in our blood and the calcium in our bones were forged in the heart of a star. We find it in the love we feel for one another, a silent, powerful force that binds us together, just as gravity binds the stars. We find our place in the quiet, not by demanding answers from it, but by learning to be quiet ourselves, to listen, to observe, and to appreciate the profound and beautiful mystery of it all. The silence of space is not an emptiness to be feared, but a deep and comforting presence, a peaceful, eternal stillness that holds us, that holds everything, in its gentle, loving, and silent embrace. Thank you so much for joining me on this long and peaceful journey tonight. It has been an honor to share these 50 meditations with you. I hope they have brought you a sense of wonder, a feeling of connection, and above all, a deep and restorative peace. If you have enjoyed our time together, I would be so grateful if you would leave a comment to let me know how this journey has felt for you. Your stories and your presence make this all worthwhile. Please consider liking this video and subscribing to our channel for more gentle stories for sleep. For now, there is nothing left to do but to let go. Let your mind become as vast, as dark, and as peaceful as the silent space between the stars. Let every thought be a distant, gentle star, shining quietly, asking for nothing. And allow yourself to drift into a deep and truly peaceful sleep. Good night.